In this video, I want to make a video on Java because some people have asked me, at least I have told them that I will make videos on Java, and they are taking that course. So they were like, yeah, great, but then I actually have to make it. So I'm working on that. And so first thing I wanted to explain to those people in the people who are learning Java for the first time, I'm assuming that they know Python because Python actually comes in like an earlier level in our degree, so they already know Python. I'm pretty sure of that. And yeah, I just want to teach them that how to actually write a Java program because yeah, because in Python we can easily just write the code like a line, print hello world, and it actually runs and prints something, and that is easy. But in Java, you can't do that. You have to make a class. You have to make a method inside that class, and it has to be that specific method, that main method, and then you write your code inside it. And like it has all of the weird syntax that you usually figure out later, because then things make sense to you, like all of the keywords that are used, like all of the keywords, like, public static, what does that mean? You figure it out, and then things make more sense. So I wanted to explain to them. Then I know that Java is kind of, I don't know, like it has to have classes. Everything should be inside classes, and methods are supposed to come inside classes, and then main function is there, main method is there because you need an entry point to the program. Because if you don't have an entry point, then yeah, like if you don't have an entry point to the program, basically the point is that I wrote a method, I wrote a function, and that function, we assume that always, like, a function is always going to be wrapped inside a class. So if I say function, then we also have a class. We can have like more than one function in a class, or we can just have one, or like, anyway. So yeah, let's say I wrote a function, or a method, but to actually run this function, I have to call it. So how do I call it? And in Java, like, I can't just call it by saying, say hello. Like, I can't just write it in the, outside of a function. I can't write outside of a function. So I would have to call the method in another method, right? But like if I call it in another method, like if I created my method, which is say hello, which basically prints something, if in order to actually run this, I have to call this function, say hello. But where do I call it? We can't just write it outside of a method, outside of a class. We can't do that. So we create another function called start, and we call the say hello function or method inside this method. Okay, so now the problem is that to run this method, we need to call it. Okay, so now we can make another class, sorry, we can make another method inside this class, and we can make another class, and then inside that we can make another method that calls this method, but then we would have to call that method. But in the end, the point is, like, if we can't have code outside of a method and to actually run a method, we actually have to call it, we have to invoke it, but we can't do that because all the code has to be written inside methods. That just leaves us in an infinite loop where we are calling our initial method that we are trying to call by creating creating another method in which we're calling it. Anyway, the point is, like, this is a catch-22. We need to have some way of like entering the loop, right? We need to have some kind of method that runs automatically, that we don't have to call. So that method is called the main method. Okay, so it says like the Java virtual machine calls it automatically. Okay, yeah, like it looks for this method and it has to be this specific method, public, static, void, main, string, args. Like it has to be this thing, because if you leave any of the keyword, then you know the JVM, I guess, like it's gonna be considered a different method. And yeah, so your program is not gonna run. Okay, so basically the main method is where we break this loop. We need to have some method which doesn't need to be called, and this method doesn't need to be called. It runs automatically. So now you can have, like, you can write as many functions as you want, as many methods, and you can call them here. Or you can just write the code here that you want to run. So you can basically think of it like, if you know Python, and you know that in Python, we didn't have to write any class or methods to do like basic coding to print something, let's say. So you can think of it like, if I have this function, I can have this main method, and which it has to be wrapped inside a class. So it should be like this. We have a class test, and inside this we have a method, and now I can just write code like I would in Python. I want to print something. Obviously, like the syntax is a little bit different, but now you could just write code. You can actually run your code. You can actually see the output, because otherwise you're just gonna get errors. It's not even gonna compile. It's just gonna give you an error. It won't even run. So yeah, this is where you start your program. Okay. Anyway, yeah. So anyway, and there was this thing like, basically, wow, time for the medicine. Okay, so I guess like if you know about the object-oriented programming, you maybe did that in Python, but we always had to, like, we would write a class, and then the class would be basically a template, and in order to actually create, like do something with that class, you would have to create an object of it, or an instance of it, like they say. Basically, we can think of it like, like they would write this thing here. I don't know, let's just say in Python, and I want to create some kind of, I want to create a, like a data type. Okay, I want to create a new data type. Okay, so that data type, I want it to be like maybe the coordinates in a 2D plane, so XY coordinates. So I want to kind of connect these two. I don't want just X value, which would be maybe an integer or a float, and a Y value that are separate. I want them in one data structure, right? So if I have, let's say, let's think about strings. We have a string class, and in those string class we have like a like one, string and sequence of characters. So we have a bunch of characters, but these characters are all together. Okay, so it's not counted as like first character, second character. Basically, it's kind of combining and grouping a bunch of characters and naming it one thing. Like we can do something like that. So anyway, so I want some kind of data type, like I can say coordinate, and then I can maybe like I can have, I can say a point P, and point P would have two values. So if I say P dot X, it will give me, a value like, 4.5. And if I say P dot Y, then it will give me a value called like maybe 7.3, something like that. So the thing is, my point is P. So P is actually an XY coordinate. And if I want the X value, then I just do P dot X, and I just do. So basically, they are inside the same variable. Okay. So how do we create, like this is another data type. So how do we create this kind of thing? So objects are just that. Okay, so basically I would have, basically think of it, this P is an object, and like we can have multiple objects. Okay, let's just say it is a coordinate object. So maybe I found a way to somehow create coordinates, basically coordinates. They have an X value, they have a Y value, and then I can have multiple of these coordinate things. Okay, like I can have multiple points, and all those points are coordinates. Okay, so I can have P, I can have X, I can have Y, like, capital letters basically. So they are different coordinates. And if I do, like, maybe I have another object X, this is also a coordinate object, let's say, then its X value is gonna be different. Okay, it's gonna be 3.4 basically. Yeah, so the point is that, if I want to create a new data type, how do I do that? Like, basically, data type is supposed to represent some kind of concept or an actual thing in real life. Okay, so in this case, I'm taking this coordinates example. And so basically, what we are going to do, we're going to define what that object is going to look like. In this case, we have an object and it has two values, right? It has two variables, let's say, and one is called X, the other is called Y, and we can store, floating point numbers inside them. So how do I define, like, this kind of object? So that is defined inside a class. So I can create a class called coordinate, and correct the spelling. So coordinates, I don't know, coordinate class, and then okay, and then you just create a class. And in Java, the syntax is like this, I hope. And I'm just gonna switch it to Java, and then you just write the fields, or the variables. They're called field when we write them inside a class. So I can have a variable called X, and in Java we have to define the type of it. Let's just say int. So I can have one variable inside it called int, and one, sorry, not int, but like a Y. Basically, I can have X and Y, two variables inside it. And now when I create an object of it, I can create an object of it like this. So I can do P equal, coordinate like this. And then now P is going to have two different, variables. One is X and one is Y. And I can set values for both of these variables like this. I can do P dot X equal 4.5, P dot Y equal, 6.5. And then, yeah, so this here, when I did this, then I actually created an instance of this class. So this class was just defining what the actual object is going to look like. The actual object is going to have two, fields. One is going to be X, one is going to be Y. And then when we create that object, but like, this isn't the actual object. The actual object is when we actually create one and give it specific values. Like when we use this keyword, or it's actually new coordinate, and here we do have to write, int, here we do have to write something. Anyway, the point is, like, when you actually call this is called constructor, then this actually creates an object that follows from this template that we have defined. So it creates an object which has two different variables inside it. And but yeah, like this, right now we haven't defined it, what the value of those variables are going to be. So they are empty, but we have defined a data type. Basically, P is going to be a coordinate type, and it's going to have an X value, and it's going to have a Y value. Like, it's going to have an X variable or field, or Y variable or field. Okay, so it's going to have both. That's what an object is. And I can create as many as I want. So I can create another object and name it, Y, okay, like X. And I can create another one and name it Y. Okay, so I can create as many, and they all have their own X and Y, fields, okay, or variables. So basically, X of this object X is going to be different. It is going to be completely different variable. It's going to have its own memory location, and yeah, and this one is different. So if we change this y, it's not gonna affect this y, okay? So they are completely different objects that are gonna have their own variables, but basically they are still gonna have the same field because this object only has these two fields, okay? So something like that. I hope that makes it clear. And yeah, like we can do something like maybe I want to make my coordinates print out in this way. Like when I print it out, when I do print x, then it actually prints it out in this way. Like if I have, x dot x equal 4.5 and x dot y equal 5.6, then when I do print x, it actually prints it out like this in a parentheses and 4.5 comma 5.6 like this. I can actually make it do that. And how do I do it? I need to do that in the class. And in Java you have to kind of override some kind of default print method. Okay, you also have to do that in Python. And yeah, otherwise, like if you actually print an object, it's just gonna give you the pointer to the object and not like print out the thing that you want, because you have to define how to print it out. So maybe like I don't actually remember how to override whatever function you were supposed to override, but you would have to do something like this, this dot x. Basically you could do something like system dot out dot print, I don't know, something like that, and then write that you print out this dot x and this dot y inside parentheses, something like that. And yeah, and you have to write this because for this object we want the x and y of this specific object. So for x we want x and y values of this object. So basically what happened is that when we call any method, then it actually sends the the object reference, I guess, also. Okay, so the first argument when we call any method of this class is going to be this, and basically if we want like if we use this dot x, it's gonna know that we are talking about the value of the object that called it. So the field x, the value of the field x of the object that called it. Okay, so that's why we write this dot x, because yeah, we want to print out the value, the field x, value of the field x of this object, of the object that called it, anyway, something like that. So yeah, this was the concept. I really made a mess here explaining all of it. I think I can probably clear things up better. I would just need to kind of, yeah, so anyway, I need to teach Java, and I need to, what was I going to teach? There was something that I was going to teach, and that was like, we have to yeah, so I was going to say like, we have to, like, we create class. Class is just, class is what? It's just a template. It's not an actual thing, so if a class has like all of these fields and maybe it has a method and all of that, then those are not actually real methods. You can't call the method. You can't really, access that field, okay? Because class is just a template. You have to create an object of it, so you create an object by using a constructor. So you do, new, and then whatever the class name is, that you defined, and that's how a new object of this class is created. And this object, now we can call the methods that we have defined in the class on this object. So we can do, x dot, maybe it has a method called, run, and we can do x dot run and all of that. So the thing is, we have a class, and then we actually create an object of the class. An object is the thing that actually has those fields, and you can give values to those fields, and you can call the method on, but if we don't create an object, like for the main function, main method, we're not creating an object, so like without creating an object, how do you How do you call a method? Like we usually call a method on an object, on an instance of that class, but we're not creating it, because to create that, I guess, like, basically the whole point of main is that we don't have to call it. Okay, so yeah. Anyway, there's a concept of like static functions, static methods, and the whole idea of static method is that, they actually belong to the class. So you don't have to create an object of a class to access these methods. So these are methods that you have a class, maybe you create a class called, I don't know, what did you, yeah, let's say whatever, class name class, and you can just call this method using the class itself. Okay, it actually belongs to the class. All right, and you can also have static fields, I guess. So you can have static fields and static fields. Like if I had a static field, and we would actually have to, I guess, write that. Yeah, like, if it's a static, you are gonna write, like, let's say static count. We create a new variable and it's static. That means, it belongs to the class. Okay, it doesn't belong to the object. So if I, like, obviously, like, we would still have access to count. So maybe I have a point, a coordinate, and we would still be able to access count, and we can kind of give it another value. Okay, maybe it was 2, we gave it 5, but what would happen is that, it doesn't belong to the object. Okay, so if I change this, maybe I use another object and I change the count to 4, this is gonna change the, like, it is gonna change for both of these objects. Okay, because this count doesn't belong to a specific object, it doesn't belong to any of them. So if you change it, you can change it, but that means, like, you are changing the actual count a variable that belong to the class. So we have some count variable somewhere, and it has a value of 2, and then you're thinking to change the value, like you think that this actually belongs to an object, and change the value to 5. This is actually going to change the value of that particular field, because this actually is more like a global, I don't know. Anyway, like, we can have global functions, global variables. Anyway, I made a mess here. Let's forget about that. We know, yeah, the count, basically, we know that for these coordinates, if I change, x value for this p, because I invoked it on p, so p dot x, and changed it to 4.5, then it is only going to change the value of, the x in p, like of this object. It's not gonna affect, x's that we define for other objects. Okay, but this is not the case for static variables. All right, and yeah, so we can have static methods, we can have static fields, and I think we can also have static other stuff that was written in the notes. We're not gonna, yeah, so what I was gonna do, completely forgot. This video was going to be a walkthrough of me trying to understand something. But anyway, to call a method inside a class, we create an object that is true. When JVM starts the program, no test object exists yet. So the JVM cannot do, because that would require creating an object first. Instead, main is marked static, meaning it belongs to the class itself rather than an object. The JVM can therefore call it directly. It can just call test.main because it is inside a test class. Okay, so yeah, that's why we don't have to create an object of it. We can just use the class name and call the function. This creates a nice flow for video 1. Yeah, Java is strictly class-based. Methods live inside classes. Methods don't run until called, but code that calls methods must also live inside methods. This creates the who starts the program problem. The JVM solves it by automatically calling main. Main must be static because no objects exist yet. Everything begins from main. That explanation is why main exists. Instead of treating it as a magical line students have to memorize. Okay, that was the thing. What does a static object belongs to a class rather than an object mean? Okay. Yeah, so that is what I was trying to explain. Yeah, it says memory, each object get its own copy of name. So yeah, let's say we created a class and then we created two objects of the class, then S1 object would have its own copy of name and S2 would get its own copy of name. Okay, the variable belongs to the object. If we make something static like school and create two objects, now memory looks more like, okay, so student class, like school belongs to the class, and then S1 student object, S2 student object. Okay, like both of these objects are not getting their own version of school, they're not getting school that belongs to them only, right? They're not getting it. So it actually comes from the class itself. So it's a notice there is only one school. It isn't stored inside either object. It is stored with the class itself. That's what belongs to the class mean. If you change it to one object, like if you changed it, then s2.school would also change, okay? Because there was only one copy in the first place. Okay, instance method. Void study create, because the method expects an object to work with. Student s equal new student s dot study. Why? Because the method expects an object to work with. Static method, now we can just call it without creating an object. Okay, no object needed because the method belongs to the class itself. A useful analogy, imagine a classroom. Each student has their own name, roll number, marks. These belong to individual students, objects. But the classroom itself, school name, principal, school address, these are shared by every student. They belong to the class. Static members are like information written on the classroom wall instead of inside each student's notebook. For main specifically, when the JVM starts your program, no objects have been created yet, so it can't do test t equal new test t.main args, okay? Because it doesn't know it should create a test object first. Instead, it directly calls, okay, which is possible only because main belongs to the class and not to any object. That's the practical meaning of static belongs to the class rather than an object. It means there is one shared thing associated with the class itself, and you can access it without creating an instance. Yeah, so I did have a question that I wanted to solve, which I forgot. I was gonna read this book to answer, like, to answer that question. I think I was thinking about like what is a JVM and yeah, something like that. And when I read the index this this is the index. Yeah, so it is saying that it's saying Java applets, and here it is saying using an integrated development environment, installing the Java development kit. Okay, yeah, okay, so this is IDE. We don't care about that. We care about JDK and building and running applets. And so I think the one benefit of having like the JVM is that Java Virtual Machine is that you can have one of it for every operating system, like one for Windows, JVM for Windows, JVM for Linux, JVM for Mac OS, and then like you can write a programming in Java, like you write a game in Java, and then it can run on Windows and it can also run on Mac OS, because JVM is gonna take the Java code and then turn it into something that the OS can understand. JVM is gonna do that, and we already make JVM for that particular operating system. So basically, if we create an app in Java, then it's gonna be cross-platform. Like we can run it on all the platforms that are available. Okay, you don't have to write that app for Windows and then that same app for Mac OS. We don't have to do that. Something like that. That's what I learned. So I wanted to make sure, and like just maybe I don't have enough information, maybe like I'm missing something, so that's why I wanted to read it. And it would just give me all of the, anyway, I'm just gonna read it. And I wanted to kind of record it so that I can later watch it and see, what I was doing, something like that. Java as a programming platform, the Java white paper buzzwords, Java applets and the internet, short history of Java, common misconceptions about Java, and all of that.